Hello students, welcome to Educate. In previous lecture, we have studied the basics of wave optics. Now in this lecture, we are going to continue from where we left last time. So let's see this question. This question says, when monochromatic light is incident on the surface separating two media, the reflected and refracted light both have same frequencies as the incident frequency y. So we have already studied that what happens in case of frequency being internal property, there is no change. Let's see the reason. Reflection and refraction arise through interaction of incident light with atomic constituents of matter. Atoms may be viewed as oscillators which take up the frequency of external agency, causing forced oscillations. The frequency of light emitted by a charged oscillator equals its frequency of oscillation. Thus, the frequency of scattered light equals the frequency of incident light. So, I think you have understood that this is the property of oscillator. Now, second question is, when light travels from rarer to denser medium, the speed decreases. Does the reduction in speed imply a reduction in the energy carried by the light waves? This is a good question. So, answer to this question is no. Energy carried by a wave depends on the amplitude of the wave and not on the speed of the wave propagation. Then comes next question. In the wave picture of light, intensity of light is determined by the square of amplitude of the wave. What determines the intensity of light in the photon pictures of light? You know, photons are constituents of light. For a given frequency, the intensity of light in the photon picture is determined by the number of photons crossing an unit area per unit volume. Then comes next question. Huygen's principle leads to the laws of reflection and refraction. By using same, deduce the expression. So here we are not deriving that thing, just we are going to next point because that is not anymore in syllabus. So here, principle of superposition of waves. Superposition of waves means two waves superpose and then a resulting wave we get. So when a number of waves traveling through a medium superpose on each other, the resultant displacement at any point at a given instant is equal to the vector sum of the displacements due to the individual waves at that instant. So if different waves are say y1, y2, y3, etc., then resulting wave will be given by y equal to y1 plus y2 plus dot 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 plus yn. Now we are going to see what is interference of light. So when two waves of the same frequency and having zero or constant phase difference traveling in the same direction superpose each other, the intensity in the region of superposition gets redistributed, becoming maximum, and at some point it becomes minimum. So this phenomena is called interference of light. Now we are going to see Young's double slit experiment. So in case of Young double slit experiment, one source is taken and then we create two slits, and from there light comes out and interference patterns are observed on the screen. So here description is given. S is a source from which two sources S1 and S2 are created whose separation is D. So here separation between these two slits is D. Alternate bright and dark band appears on the observation screen. These are called interference fringes. When one of the slits like S1 or S2 is closed, bright and dark fringes disappear. It means what is happening? Due to the interference of light from these two sources, here S1 and S2 are behaving like two sources of light. and so the disappearance and intensity of light becomes uniform. Now we are going to see the basic conditions for constructive and destructive interference. So we assume two waves, one is y1 equal to a1 sine omega t and another is a2 sine omega t plus phi. So here there is phase difference phi. Now when these two waves superpose, then resulting equation is y equal to y1 plus y2 or a1 sine omega t plus a2 sine omega t plus phi. Now here we can apply formula sine a plus b, that gives sine a cos b plus cos a sine b. So what do we get? A1 sine omega t plus A2 sine omega t cos phi plus cos omega t sine phi. Now we further write sine omega t term here. We take out, then A2 cos phi will be left and here A1 will be left. So we write A1 plus A2 cos phi sine omega t plus from here A2 cos omega t sine phi. Now we make certain assumptions. These bracketed term, here this term and here this term, we can assume them as a1 plus a2 cos phi equal to a cos theta and a2 sin phi equal to a sin theta. Now we can square the two equations and we add. So when if we put this value over here, so this will reduce to this form a sin omega t plus phi, which represents a wave. As I told you, now we are going to square this equation and add. So when we square this becomes a square cos square theta and this becomes a square sin square theta. So we write together. So a square cos square theta plus a square sin square theta. And now we square this term. So this will become a1 square plus a2 square cos square phi plus twice of a1 a2 cos phi. So this thing, and here when we square this a2 square sin square phi and then we expand. So a2 square cos square phi, here a2 square sin square phi will become 1. So we will get this result, a square cos square theta plus sin square theta will become 1. A square equal to a1 square plus a2 square plus twice of a1 a2 cos phi, right? But intensity is directly proportional to square of the amplitudes, or I equal to k times a square. So here we can write I1, here we can write I2, and in place of a1 a2 we can write square root of I1 I2, and this can be a square can be written as I. So this is our final equation. Now this I will depend on cos phi. When cos phi is 1, then this will become I1 plus I2 whole square, and that will be root I1 plus root I2 whole square. So that will be maximum. So here we can say that this term is called interference term. Now we are going to interpret the same thing. So constructive interference, as I told you, when cos phi has maximum value, that is 1, in that case this term will become root I1 plus root I2 whole square, that will have maximum value. So cos phi is 1 when phi equal to 0 or 2 pi or 4 pi. 2 pi corresponds to path difference lambda, as you know very well. So here for path difference p, we can write this relation 2 pi p by lambda equal to either 0 or 2 pi or 4 pi, from where we can get the value of p. So 2 pi will get cancelled. So we will get value of p as 0, lambda, 2 lambda, etc. So this is case of constructive interference. Now we are going to see the condition of destructive interference, means the cos phi term becomes -1, and we know that cos phi will become -1 when phi will be either pi or 3 pi or 5 pi. So in that case we can get 2 pi by lambda times p equal to either pi or 2 pi, etc. So this is wrong, this is not 2 pi, this is 3 pi, right? Because pi, we have to write these values. So this equal to, so pi or 3 pi or 5 pi. So this becomes p equal to 2n minus 1 lambda by 2, right? Now we are going to talk about coherent sources of light. So sources emitting light of same frequency and having phase difference 0 or constant are called coherent sources. So other sources in which there is certain phase difference and it's not constant, in that case we say that it is The sources of light which don't emit light waves with a constant phase difference are called incoherent sources. Now, here there are certain statements you must know them, like two independent sources can't be coherent. The logic is very simple. Reason, let's see what is the reason. Light is emitted by individual atoms and not by bulk of matter acting as a whole. Even a tiniest source consists of millions of atoms, and emission of light by them takes place independently. So these are the reasons. And then here one more point is that even an atom emits an unbroken wave of about 10 power minus 8 seconds due to its transition from a higher energy state to a lower energy state. Now, our question is how to get two coherent sources. So, the two sources of light, first of all, conditions for obtaining two coherent sources. So, the two sources of light must be obtained from a single source by certain method. The two sources must give monochromatic light. Then the path difference between the waves arriving on the screen from the two sources must not be large. Now, here we are going to solve one question. The question is, so let's stop here. We can solve the question in next video. Thank you for watching. Team Educate.